Today we're going to be discussing why protons identify the atom. What we're going to be looking at when we're talking about this is the periodic table. And so here I have an element square of oxygen drawn so that we can talk about where we can find the protons and why they identify the atom. So we have four things listed here on our element square. We know that this bottom word is just the name of the element. Right above we have the atomic mass, which we know is the number of protons plus the number of neutrons. Remember, we find most of the mass for the atom in the center, in the nucleus. Here in the middle, we have the atomic symbol. And the atomic symbol is composed of 1 to 2 letters, always beginning with a capital letter. And then at the very top, we have the atomic number. For today's purposes, we're really going to be focusing on the atomic number. The atomic number tells us the number of protons. Because we're only looking at neutral atoms, we know that if we have 8 positive particles, we're also going to have 8 negatives. So not only does the atomic number tell us the number of protons, but it also in a neutral atom tells us the number of electrons. But we're really going to focus on the fact that it tells us the number of protons today. So this is just one square on the periodic table. Here's a copy of the periodic table. You'll notice that the periodic table is made up of over 100 different element squares. So as we're looking at this periodic table, if we know that the number at the top tells us the number of protons, you can recognize a pattern on this periodic table that as we move to the right, just like we were to be reading a book, the number on the top is increasing by 1. Hydrogen is our first element on the periodic table. It's our smallest element as well, and it only has 1 proton, and that's indicated by the 1 in the atomic number. Helium has 2 protons, which is indicated by its atomic number. Lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, and so on. Every single time we move to the next element, we increase our atomic number by 1. And what that means is that every time we move, we are adding 1 proton. So when we talk about the fact that protons identify the atom, we first need to talk about what the word identify means. To identify, and we can write that out here, to identify means to establish or to recognize. So we'll say to recognize or establish. So just like whenever you hear the word ID card or identification card, it's the same idea. The identity, to identify, is to recognize or to establish. Anytime you see an atom, even if you're looking at a Bohr model, that has 3 protons inside of its nucleus, it doesn't really matter what else is going on with this atom. If you can see the center and see that there are 3 protons, you can come over to your periodic table and all you have to do is find the number at the top, the atomic number that says 3. 1, 2, 3. That is an atom of lithium. Now, if you are only given the nucleus and they say the protons are 65, that would be a pretty difficult Bohr model to draw, especially in 8th grade. So all you would have to do is, knowing that the atom has 65 protons, is find the element with the atomic number 65. They go in numerical order, so as you move down the periodic table, our elements are getting bigger and bigger. You'll see here that this area branches off. We're looking for element 65, and that's right here. Easy enough. We could do it again. If we're told that the element inside of its nucleus has 42 protons. Again, you don't have to draw the Bohr model. We don't really have to do anything else to figure out what element we're looking at. We're looking at an element with 42 protons. So we can find the number 42, 38, 39, 40, 41, 42. So anytime you know how many protons an element or an atom has, it's very easy to find what element we're talking about, because the top number, the atomic number here, tells us the number of protons. And protons ID or identify an atom.